This video is about organic analysis. That's the method to identify the presence of an organic compound. The first, what we want to discuss is about how to identify the presence of double bond in an unsaturated hydrocarbon. Unsaturated hydrocarbon, such as alkene, has a double bond in the carbon chain. The presence of the double bond in an alkene can be identified by the using of bromine water. Bromine is Br2 will break one of the bond pair between carbon and carbon atom in an alkene, and the double bond will break into single bond and bind with Br. So the brown color of Br2 will disappear or decolorize. We continue with other identification of organic compounds. This is the formation of ester, a group of compounds with specific sweet smelling, and the formula is RCOOR. The ester is the product of a reaction between carboxylic acid with formula RCOOH and alcohol ROH. The OH of the acid will join with the H from the alcohol. Then this form water. The rest of the substances is RCOOR. These two substances provide a simple test reaction for each other, meaning that we can test the presence of an alcohol by using a carboxylic acid, then they form an ester. Or we can use an alcohol to test the presence of a carboxylic acid, and then they react to form an ester or RCOOR. Next, chromatography. Chromatography was originally used as a method of separating colored substances. However, the usefulness of the technique has been extended by the use of locating agents to detect the presence of colorless compounds once the chromatogram has been produced. Here, for example, we have paper chromatography. This part dip in a solvent, and then the substance we want to observe we put in here on the paper, and then the solvent will go up the paper and separate the component of the mixture. After some time, then we have the chromatogram like this. Experimental design and investigation. First, scientific method. We start with an idea and then we do some research to discover, then develop a hypothesis, then plan and carry out experiments. Next, analyze the result and conclude it. The last, we write a report. Planning investigations and controlling variables. Suggest a hypothesis, an idea to be tested. Is it a problem with worthy of testing or not? And then draw an information from notes, the library, CD-ROMs, and the internet. Then continue with draw up a plan of experiments to test the idea. And in this step, you can consult with your teacher. And we decide which variables to check and which to keep constant. Choose the apparatus and chemicals needed. Then carry out the experiments, making notes, and record the measurements. And then draw up a summary of the result in tables and graphs. Draw conclusions and try to decide whether the results support the original idea or not. Do they suggest further tests and ideas? Then we can back to the first, suggest a hypothesis. In planning investigation, we need the hypothesis, variables, and then selecting apparatus. We need to consider the safety, and we need to think of sources of error and display of observation. Here are some apparatus. First, you have a test tube, and then boiling tube, beaker, conical flask, measuring cylinder, graduated beaker, evaporating dish, condenser, Bunsen burner, tripod, gauze, filter funnel, eye protection, a Google, dam and stand or retort stand, burette, siring, dropping pipette, stop clock, balance, mortar and pestle, thermometer, volumetric pipette, and spatula. Spatula is like a spoon we use to take solid. Boiling point, boiling tube and test tube we use for carrying out some reaction. Beaker to hold a liquid or solution. We cannot use a beaker to measure the volume, just approximate. Conical flask for titration and other experiment. Measuring cylinder to measure the volume of liquid or solution. Graduated beaker with some scale for holding or keeping liquid. Evaporating dish to evaporate something. And then condenser to condense steam. Burette for titration. Siring for measuring the volume of gas. Dropper for delivering liquid or solution in drops. Mortar and vessel for grinding, thermometer to measure the temperature, volumetric pipette to measure a certain accurate volume in titration using together with burette, and spatula to take solid. We have here another laboratory equipment. This is test tube rack to put some apparatus. We have tongs, and then we have steering rod to stir up a liquid or solution. The chemical safety symbols, you have irritant, substances that can make your skin go red or blister. If they are dry powders, they can cause coughing, example copper carbonate, CuCO3, and calcium chloride, CaCl2. Toxic, highly flammable, catch fire easily. For example, ethanol and hexane. Harmful, the same as irritant, but with I. Here, harmful with H. Oxidizing, corrosive. Corrosive substances that will burn the skin and damage the eye. They can damage wood and metal, for example, sulfuric acid, sodium hydroxide. Plotting graphs. Label each axis clearly with the name of the variable and its unit. Give your graph a title. Plot the points with a cross or dot using a sharp pencil. Draw the best fit line, which does not have to pass through all the points and which may be a straight line or a curve. Plot the controlled variable. Plot the dependent variable. Remember that the scales do not have to start at 0. For example, here you have the variable is temperature as x-axis and time as y-axis. Then you put some data in cross or dot in some places, same as you get from the experiment, and then draw a line. Don't have to pass all the dot or cross. To reduce errors can be reduced by using apparatus that gives greater accuracy, by making measurements more carefully, or by making multiple measurements and taking an average. Systematic errors can be eliminated by using accurate apparatus and improved techniques. Here we have example of full experimental technique when we measure a volume of a liquid. The position or the level of your eye should be the same as the level of the surface of the liquid. Not like this.